Okay, excellent. Well, thank you everybody for joining. So I'm Lonnie Chrisman. I am the CTO here at Lumina, and that's a picture of me on the screen you should be seeing. That was in September. I went to Iceland and was able to get up close to an erupting volcano. So that was pretty cool. And today I will be talking about decision making when you have little or no historical precedent. And okay, and I got to fix something here. There we go. Hold on. I got a little dot on my screen. Okay. So from today's talk, you'll learn that there's an approach and some tools to improve your skill as a decision maker. And the outline, generic outline here is basically I'll introduce the problem, the approach. We'll do an exercise that will be probably half of the entire talk. I'll talk about how software can help us, applications that we've done at Lumina, and some resources. Oh, and I guess the other important thing about this is as I hit each of these sections, I will put a transition slide up, which will help to be a cue that you can wake up if you've phased out a little bit from the previous section. So what do I mean by historical precedent? Well, basically it means that there are situations in the past that are substantially similar to what you're facing now. You know, that the past is predictive of the future. And this idea that the past is predictive of the future is really the core of many of the high profile technologies that we hear about all the time. Pretty much anything that relies on data for its power, like machine learning and business intelligence, analytics of various forms, and visualization, and so on. But when this doesn't hold, it calls into question the usefulness of those tools. And so I'm interested in seeing if we can move beyond that. So when do we lack historical precedent? Well, we might be doing something fundamentally new. We might be considering a new initiative. You know, perhaps it's a new product launch for some product that's never been tried before, or a novel business model. If you're a government, you might be interested in understanding what the impact of a new proposed policy or new regulation might be. Or perhaps the world just changes out from under us. Maybe that's due to technological shift, climate change, the onset of a pandemic, changes to your competitive landscape, or new rules and regulations that emerge. Now, these kinds of situations tend to be the hardest decision situations that we faced, but they're often the most important as well. And they're the focus of areas like strategic planning and risk management. So when people are faced with difficult decision situations like that, they often exhibit many shortcomings. For example, people tend to focus too narrowly. They don't consider the space of objectives and don't necessarily clarify them well. They don't consider all potential decisions that are within their control and decision opportunities, and they often don't consider all the uncertain outcomes that may need consideration. They often anchor often to ideas that they come up with early in the process, and then they don't stray very far from that. And this can also lead to advocacy, where different decision makers advocate for their own opinions, and each decision maker basically spends their time seeking out confirmational evidence, and this really can destroy communication. People just talk across each other. People experience decision paralysis. I mean, these situations are hard. It's confusing, it's uncertain, and so people sometimes just don't know where to start. They don't know how to proceed, and stuff. Sometimes decision paralysis because they're afraid they might be held accountable later for their decisions. People commit prematurely. This is the proverbial flip of a coin, and that is not always a very good thing to do if there's value and time and opportunity to do further analysis to really make better decisions. But on the other side, people also rely too blindly on analytical results, and people succumb to numerous other cognitive biases. Okay, so what I'm advocating here is an approach to address these shortcomings. So this is my transition slide, as I promised. So I want to start with an observation, and that is that it's usually easier to move from concrete examples to generalizations rather than the other way around. And so what this says is when we have these really confusing, difficult situations like this, if we can promote concrete thinking initially rather than broad, abstract ideas, that's going to help you actually get a foothold and have something you can work off of. And so my approach is to build a decision model interactively. This will be visual yet quantitative decision model. And it's through that process, that hands-on process of building the model, that allows us to gain insight and clarity. And so this is a prescriptive approach in that it gives us a sort of a recipe where to start and how to proceed. And it encourages you to clarify objectives and decisions and to consider, what other objectives and decisions might be possible. It tends to guide you towards precision and clarity. It helps you identify unknowns, things that would be useful to know, and realize, that if you knew these, it would help, and this is how it would help. It allows you to weigh trade-offs, to account for uncertainty, to explore different assumptions, and to merge diverse opinions. Now, one of the buzzwords that I hear all the time recently is everyone saying we should be doing data-driven decision-making. And, this doesn't quite work, I think, when you don't have historical precedent. So what I'm advocating here is a generalization of that, which is called model-driven decision-making. Okay, so that's the mantra. We should be doing model-driven decision-making. And model-driven decision-making has numerous advantages. Okay, by moving you toward precision, clarity of ideas, it forces a more nuanced and evidence-based approach to decision-making. By making your assumptions and your estimates and your logic explicit, it gives you something that's critiquable. It exposes relationships, gives you a way to really get a deeper understanding of how assumptions lead to outcomes. It allows you to do sensitivity analysis to really understand which assumptions or estimates actually matter. It fosters communication by transforming those advocacy arguments that go nowhere into more constructive discussions about specific assumptions. It enables you to assimilate complexity, identify knowledge gaps, and a model can help to document your decision rationale at the time you're making your decision, which gives you something useful to look at later on. So, I assume a lot of you have probably had experience in some decision situations using spreadsheets, linear programs, or programming languages like Python, maybe doing simulations, to help you with model-based, supposedly model-based decision-making. But if you did, I am pretty confident you probably did not experience the benefits that I just listed on that slide. And unfortunately, these frameworks are often counterproductive. They kind of encourage you to narrow your focus early, and to anchor on your initial formulation, by making it sort of requiring you to structure things and make commitments to structure and dimensionality early, and then making it hard to change those. It's not prescriptive. It doesn't give you a distinct recipe for go forward. And these are inaccessible. So first of all, linear programs, programming languages, most decision makers really don't know how to even do those. And spreadsheets, quickly become incomprehensible at even a moderate level of complexity. And all of these lack transparency, once they really end up being black boxes. And that tends to also promote an over-reliance on analytical results. So, what I'm going to do here is I'm going to do this in backwards order, but again, this is consistent with my belief that we cue off of specifics and concrete things better. So before really discussing generalities, we're going to dive into an exercise, okay? And we're going to work this out interactively. So I encourage you guys to shout out ideas as we go through this too. And what I'm trying to do here is this is going to be live. I'm trying to pick something quite challenging, actually. So here's the set. Imagine you run a mid-sized digital marketing agency, and historically everybody has worked out of the central office in person. But then the pandemic hit, and today you need to design a work from home policy. And the reality is you really have no idea how to go about doing this. You have no precedent for this. You've never worked had people working from home, but this is really critically important to the future of your company going forward. And so how do we about doing working this out? So where to start? So what I want to say is you should always start with objectives. Okay, so think about what your objectives are, things you might minimize, maximize, or achieve, and try to list these out. And then after you have a few of these, narrow your focus. You want to start small, and you want to get something going as quickly as possible, move towards the concrete. But right now you want to stay qualitative, okay? So maybe pick one of these, and then ask, what decisions are under my control that might be relevant for that objective? And so identify a few decisions and then connect them. Try to figure out how those decisions, can be connected to that objective. Also, then think about all the other things you might need to know. And again, do this qualitatively. And this process at the qualitative level is collaborative. I mean, it actually works really good if you can do it with multiple people sort of looking at the screen at the same time and stuff. So, you'll find that even people who aren't very quantitative are can actually quite well at this stage. This turns out to be the hardest stage, this qualitative stage, believe it or not. But then once you get something small, then I say we move to the quantitative. Now, of these things, the one thing that really deserves a special emphasis are objectives, because these are often the most overlooked step, but often also the most valuable step of the process. And believe it or not, these tend to be the most difficult step. In fact, Mark Twain had this quote I like. He says, "I can teach anybody how to get what they want out of life. The problem is I can't find anybody who can tell me what they want." So that's kind of an emphasis of how hard the objective step is. But by actually sort of really pushing yourself in that direction, it's very useful. I listed some examples of objectives here that was meant to be kind of something that's useful for discussion. I'm not going to go into that for the sake of time right now. Some of these are pretty good examples, and some of are ones that you can discuss why they might need to be refined a little bit to be more precise and unambiguous. So if you teach a class or something, I certainly welcome you to use that as a discussion point. So now, though, what I'd like to do is actually jump into building the model. And I think it's going to be more useful if I unshare maybe and then share just the application so that the resolution is more favorable. So I'm going to try switching over to just the application screen. If that worked, you should be seeing the Analytica application. It's kind of in a blank state right now. Somebody put a thumbs up somewhere in the chat if you can.
I can see it, Lonnie.
All right, awesome. Okay, so I'm not going to spend my time explaining this. We're just going to jump in and do this stuff. And as I kind of pose questions, I'll proceed, but I love you to put your ideas in the chat as we go too. So this will be our work from home policy model. Okay, so the first step is identify objectives. So now let's think about this. What would the objectives be in this example? Okay, we're this mid-sized company. We're going to have people working from home. What kinds of things should we be thinking about? Okay, so I know that a lot of people retain a creative environment. Awesome. Okay. Okay. So, and I know that people kind of expect to be able to work from home. If we restrict that too much, we might risk losing people. So I would say employee turnover might be one. Avoid slacking off. All right, I'm going to call that productivity. How about that? Oh, my caps lock. All right, maintain profitability. Okay. And I'll just say profitability. Maintain a feeling of participation. Oh, I like these. Okay. Okay. I misspelled something there, but I'm not going to take the time to change that. So very good. I like these. I like these. That kind of gives me an idea too, which is just foster a culture. That's similar. Okay. Customer base. Okay. Yeah. So something about customer base. Convenient, support the customer base. Okay. Excellent. I imagine there might be some cost savings for maybe being able to shut offices down. Profitability, a result of some others, meaning we should be distinguished between instrumental and terminal objectives. Yeah, okay. So yeah, profitability, it may be a little bit too broad, and this is a good point. So some of these objectives are are at different levels. So we can imagine profitability might be broken down into some sub-objectives. So so that's good. Marketing, let's see, is that, so we are a kind of a marketing, digital agency marketing company. I guess marketing ourselves, not positive. Enhance job satisfaction and work-life balance. Ooh, I like that one. I like that one. Okay. I'm going to especially do work-life balance. Okay. And of course that applies to the employees. And we're getting probably to the point here where we can pick something useful to zero in on, which is cool. Sales is maybe overlapping with support customer base to some degree. Maybe there's something a little more specific. Again, sometimes these things can be broken down into some lower level objectives. So that's cool. And I think there's a lot more too. Expand customer base. Okay, excellent. I'll stick that down there too. Okay, so what I want to do now is focus in on one of these, and I don't want to pick one that's too easy. I think I think productivity might be a good one. So let's zero in on that one. I'm going to just throw this into its own module here, so we have a less clutter as we work on this. And I'll put the objective on the right. Okay, so the first thing we need to say is, how can we be more precise about what productivity means? It's kind of a broad thing now, so we like to sort of clarify these and think about something that might be quantifiable. So, I think productivity, first thing I start thinking of is like KPIs. These are performance indicators, key performance indicators, like how many videos you make and stuff like that. But that's that stuff. So which perspective are we doing the analysis? Who makes the decision? So we're imagining it's kind of, this is really for us to develop the policy as being somebody who runs the company. So that's kind of the perspective I'm imagining here, and we're going to kind of fill in the details of the hypothetical situation as convenient. I think those key performance metrics don't quite get at what we want here. I think maybe more like, I'm going to say relative productivity might be better, and that is really the sort of the productivity compared to what we had before. So I'll describe that down here. So the productivity under the policy, work from home policy, relative to pre-pandemic all in office productivity. Okay, so a value of 1 would mean that we have the same level of productivity. A value of 1/2 would mean we're half as productive, and a value of 2 might mean we're twice as productive. So let's see. I think that's clear enough for now. And so now we have to say, like, what decisions would be relevant here for determining productivity. So I guess an obvious one. Okay, so another to do here is we have a lot of complexity. Oh, so how do I define productivity? So I just defined relative productivity. I think we really want to talk about how productivity changes here. So I said we're going to define it as sort of how much productivity changes relative to what we used to do. And so a value of 1 would mean that we're equal productivity to how we were when everyone was in the office. So it's like a multiple. Okay. So okay. So at this point, we have dozens of employees and many different work groups, and lots of complexity with the company structure and stuff. And so what I want to do here is eliminate as much as that as we can initially. And so one way to do this is just kind of imagine just talking about maybe a hypothetical employee at this point. Okay, and maybe if we're going to put this over different roles that people have, that would be a dimension that comes in later. And so so that's going to help us to narrow this to something we can get going. So if we looked at immediately to looking for something quantifiable, don't you run the risk of the proverbial looking for your under the lamppost because that's where the light is? I suppose this is the question of how do you tell whether your quantified definition really captures what you're looking for? And yeah, so that's a good thing. So the value of trying to really define this in a way that is quantifiable is that it really forces you to be complete. So Ron Howard had this idea of a clarity test or a clairvoyant test that said, we want to really try to define our concepts, our variables or ideas in a way that somebody who in the future or who knows everything, could look at it without making any sort of judgment calls and, really know what the true value is. And so as we push towards that, it allows us to sort of minimize ambiguity. Now, at this stage, we don't want to get obsessed with being overly precise, and so that kind of gets at your thing. You want to find stuff that gives you sort of a qualitative feel, because it's not the numbers as much as it is the sort of qualitative interaction, qualitative directions things move. And so I think having a relative productivity, that's sort of enough. But what's important here is the ability to move towards the concrete early is really what gives you a springboard, okay, when you're in this situation where you just like, it's just really complicated. You don't know where to start. You don't know how to doing it. And once you have it concrete, it's a lot easier to move from there to something better. So that's kind of the goal, is to get concrete early. And that's why there's a move. But right now what we're doing is we are staying quantitative in terms of identifying all the factors. We just want to make them clear. Okay, so one decision idea that seems, okay, again, think of this as like one employee, but would be the actual percent time remote, right? The more, and that's something that maybe we have a little bit of control of in our policy, is how much people work remote. Okay. So, I kind of feel like there's lots of other things I want to stay kind of as relevant as I can before I start throwing too many random decisions out. So maybe it helps just kind of maybe now think, well, what kinds of things might determine productivity? So, so one thing would be the environment, right? So I'll say relative productivity due to environment. So I can imagine, at home, I might have or people might have a bigger risk of like getting sucked into Facebook or the kids or something. So, but maybe there's other, advantages too. So there's some productivity due to the environment. Another thing, I guess, when I think about productivity, people kind of have this period of time when they're working by themselves. They're focused, they're getting work done, and that's where the productivity occurs. And then there's these other moments when you're in a meeting or you're interacting with somebody, and those aren't directly creating stuff, but they help in some cases. So if you're stuck and you can turn around and say, hey, can you help me with this? That can prevent you from wasting a lot of time. Or if you need some information right away and you can turn around and say, hey, can you give me this information? That can help. And meetings can be full for kind of keeping you on track, right? So it seems like to me interactions have a big part of this and are pretty relevant to the difference between work at home. So so actually, let's say relative productivity due to interactions. Okay. And okay, and so I imagine that working from home, you're less likely to interact as much. So maybe some of our policy decisions would be related to encouraging more interaction. Okay, so so maybe we require you to have, one idea is require you to required meetings, require you to have a certain percentage of your time spent in meetings, so, so you can kind of touch base and make up for the lack of your other conversations. So there's a couple decisions. Okay, that might be good for right now. So how, what determines the relative productivity due to the environment? Certainly the amount of time you're remote, because there's going to be a difference between home and work. And so the relative productivity from home would seem to be relevant. And so we're talking relative to the baseline of what was before. That seems like it should be sufficient for that one. How about relative productivity due to interactions? Well, I mentioned, let's see, we had meetings, that have a certain purpose of keeping you on track, like these spontaneous interactions of asking questions or asking for information. It seems to me that's kind of important. I don't think this decision is going to have much influence on spontaneous interactions, but it might affect meetings and stuff. So even though I try to avoid introducing dimensions at this stage, I think this one's, actually distinguishing between a few interaction types would be useful. So I'm going to just say we have scheduled interactions like meetings, and we have spontaneous, which would be when you're remote. It means you pick up the phone, or you buzz somebody or whatever. And I can imagine later on we might elaborate and have emails and IMs and other kinds of interactions, but let's keep it simple as possible right now. So that means we have kind of a net relative productivity due to interactions, and then we might actually subdivide that into relative productivity due to interaction type. Okay, and so now we ask, how would we come up with the relative productivity change is due to interaction type? What does that depend on? So, I mean, I guess the first thing that comes to mind is the amount of interaction, right? And maybe comparing that to a baseline, which might be how much interaction we used to have before the pandemic when everyone was in the office. And maybe also relative to some ideal level of interaction. And I made that a chance because I'm figuring we don't know what the actual ideal level of interaction is. That's going to be an estimate. Baseline could be an estimate, but let's just kind of imagine that we know our business pretty well, that we know that. So, so the amount of interaction. So what determines the amount of interaction? Certainly the percent time remote and the required meetings. So probably we could talk about the amount of interaction when we're 100% remote. Okay, and that would that would certainly be influenced by required meetings, and the amount of interaction would be influenced by how much time we're remote. And I imagine that this is is going to vary by interaction type. So let me actually turn arrows on. I don't normally turn arrows on for indexes, but right now it can be useful. Okay, and in addition, I think that the ideal interaction might vary by interaction type, and our baseline might also. Okay, so this is a good level now. And as I mentioned, we want to do this quantitatively. We want to get something small, and we want to get something. We want to be able to move to the quantitative level quickly, because that concreteness helps. Okay, so even though this is going to be a fiction because it's very simplified and everything, getting that concrete starts to get starts to give insights. So what I want to do now is fill this in. I'm going to skip over some steps that I really don't like people to skip over, which is just for the sake of time. But you should really describe each of these. Fill in the description for all of these to make sure that you kind of have a clear idea, as clear as possible, about what you mean by each of these. one thing that might be useful is to actually fill in units of measurement is useful. I notice these guys right here are likely to be a percent. Let's talk about each of those being a percent of your day. You know, what percent of your day is spent remote, required meetings, interacting, and so on. So it might be convenient just to set the number format for those to be a percent. Okay, so I'm going to start filling it in though, without kind of going into those other steps. So the relative productivity is a multiple, and we have these two inputs. So I think it's just going to be the product of those guys. Okay, I mentioned that usually drawing the influence diagram, the part we just did, that's the hardest part. I mean, that is the most conceptually difficult. That is usually the hardest part. The filling in part, although it feels kind of technical, it's usually the easier part. Although, you know, it can get advanced, but as far as, you know, figuring out how to, you know, how to formulate your problem. So this is not that deep, but anyway, so the relative productivity due to the environment, that's going to depend on how much time we're at home. So, you know, it's the percent time that we're at home or that we're remote times the productivity, the relative productivity at home. And then when we're not at home, that would be 1 minus the percent time remote. Then our relative productivity would be 1 as we're relative to our baseline. Okay. Okay, so that gets us to this one right here. Okay, what is the relative productivity at home? This is clearly something that we don't have much idea about. I don't have much idea about. How productive are people? You know, how conducive is the home environment to productivity? So what I'm going to do is I'm going to express uncertainty about that. And whenever I express uncertainty, I almost always turn to this function, which is uncertain, low, medium, high, which lets me just kind of put in a low estimate, a medium estimate, and a high estimate. Okay, so I can imagine at the low end, you know, it's possible that relative productivity might be 6% of what it would be in the office. I kind of feel like it's probably close to, maybe slightly less than it would be in the office. Is kind of the best guess. And, you know, it's possible it's dramatically more. I'm very uncertain at this point. And the final thing is, you know, you want to kind of express whether this is an unbounded quantity or bounded quantity. And this is a positive only quantity. So I'm going to put a lower bound of 0. Okay. So this uncertain LMH is just a generic function for expressing uncertainty. That's a good go-to. And when you do that, I'll show you the result. What that does is it actually defines a probability distribution, okay, which in this case looks like this. So among each of these relative probability possibilities, you know, this is the, you know, you can compare this to other relative probabilities here to see kind of what the probability distribution looks like. Okay, and actually, if you look at the cumulative, I'll just mention my estimate of 60%. It was actually the 10 percentile. So what I effectively did, if you're familiar with the terminology, is I did a 50-90 assessment, but that's details. Okay, so I'll just stick some placeholder in here. Imagine we're 50% remote, just as a placeholder. Okay, so what's our relative productivity due to interactions? Well, it's based on interactions by type. So kind of as before, so they're multiples. I'll just do the product of those over the interaction type. Okay, let me move that arrow to be a little more, ooh, that's not what I wanted. I wanted the square one. Yeah. Okay. Okay. And this one is going to be some function of these three. And I'm going to put that one off. That one looks a little more difficult. The amount of interaction that I have, well, it's going to be the interaction when I'm remote times the percent time that I'm remote. That's easy enough. Okay. And then when I'm not remote, that's 1 minus the percent time remote, going to be actually probably similar to what my baseline is. Okay. I'll just assume that our productivity in the office is like it was in the old days in our baseline. So for our baseline, we'll fill in something for this. I'm going to make it a table so we can vary over interaction type. And what I'll do here is I'm just going to assume we know our business good enough. I'll put something in here. Assume this is kind of historically what our levels of interaction. Okay, they're meetings about 10% of the times because this is a creative marketing agency. People spend a lot of time discussing concepts, and maybe people also spend a lot of time talking about their personal lives and stuff too, so that not all that's productive. So maybe when we do the ideal interaction, should also be a table, we should take into account that maybe not all that's productive. So since this one's uncertain, I am going to put actual distribution here again, actual estimate, I should say. Okay, so let's say ideally we probably have more meetings than necessary. Most companies do. So ideally, probably the ideal level is probably a little bit. And this is a percent of our time. So this is going to be a lower bound of 0 and an upper bound of 1. Okay. And we'll do something similar here for spontaneous interaction. We'll have to come up with some numbers here or some estimate here. So again, we're kind of being loose with these things right now, but try to spread things out a bit. Imagine that, I'm going to shoot a little lower than what our historic interaction was because people, like I said, maybe shoot the bull a little bit too much. So perhaps that much interaction isn't completely productive, but there needs to be a pretty high degree because we are creative level. So that's kind of my ideal estimate. Interaction when people are 100% remote. Okay. Again, it's going to vary. So I make it a table. Okay, for simplicity right now, let's just say this isn't very accurate or very good, but I was going to say we're going to imagine that the amount of scheduled interactions is going to be exactly what we require, and for spontaneous, we'll stick in an actual certainty again. So when people are remote, they're probably not interacting that much. So I'm going to lowball it a little bit more, but with a pretty good size spread. Again, since this is bounded by 0 and 1, I'm going to put that in there. Okay. All right. I just wanted to see if yeah, okay. So just to kind of show you again, if I looked at the results of this ideal interaction and looked at it as a probability density here, I could see that, basically it's ended up defining a distribution over the ideal interaction. So that's an explicit description of the uncertainty. Let's see, this guy, let's just stick a placeholder in here. Maybe we require 15% of our time in meetings when we're remote. Okay, we'll up that a little bit from the 10% historical, as they probably need a little more interaction forced on them to stay productive remotely. And so the last thing we have is this one. So how can we kind of come up with some kind of relationship of relative productivity based on baseline, the amount of interaction relative to a baseline and relative to the ideal interaction? So I'm gonna, let's see if I can do this on Zoom here. I'm gonna grab a drawing tool if I can. Draw, how about that? Okay. Okay, so I'm thinking this. So imagine that this axis is productivity, relative productivity from interaction, and this axis is interaction. Okay, interaction and relative productivity. Okay, and there's some ideal amount of interaction, and that is our maximum. Okay, and if we don't interact at all, then we're going to have zero product. I'm sorry, if we interact 100% of our time, we're going to have zero productivity. We're not getting anything done. And if we don't interact at all, we're not going to have any idea what to do. It's going to be pretty close to zero interactivity, zero productivity too. So I imagine that there's some sort of convex shape where we have our ideal right here at our maximum, and we have some reference as our current amount, which if I could make that hit the curve there, that would be where the 1 occurs. Okay. So that's kind of what I want. I didn't mean to make my curve so symmetric. I maybe should have made it like, if our ideal is off a little bit, it might be like that. Okay. So anyway, that's kind of what I'm imagining. And so I'm gonna so we want to make this guy reflect that. Now, when I hit a situation like this, I don't want to pollute the definition here with all that complexity or all that specific stuff. So I'm just going to imagine we have some sort of productivity function available to us that has that shape. Okay. And specifically, I'm going to open up the object window for that productivity function. Specifically, what we have is some function that takes x, a best x, and a reference x. And it's going to give us this convex function. Okay, so it's going to be a convex function on x, which is going to be between 0 and 1, with a maximum at best x and a value of 1 at ref x. Also a value of 0 at x equals 0 and x equal 1. Okay. Kind of a, okay. And so I just got to come up with some sort of function that kind of fits that shape, make something up. At this point, the specifics isn't what's important. It's kind of getting something that sort of qualitatively behaves like that. So what I like to do is I often like to also just document and check that the parameters are all in legal range here. So all of these are should be between 0 and 1, right? Okay. All right. So how do you come up with a convex function that has a maximum of best x? What comes to mind for me would be this. There's lots of different ways to do this. This just kind of jumps out at me. I have dealt with things of this shape before, but basically it's like two exponentials coming from each side that intersect at best x. So the maximum ends up being at best x. And so that should give us a maximum there. And just to kind of check that, I'll just temporarily put a variable in here where I can graph it. Oh. Okay, so let's put the ideal at 0.1 and our reference at 0.3, and see what we get here. So, okay, so it looks like indeed it is maxing at 0.1, and I haven't used the reference yet, so it's not at 1 yet there. So now I just got to make it normalize it so that it's 1 at the reference. So that should basically just be a matter of dividing by the same expression with x replaced by ref x, right? And that will normalize it. So this is, this part's not super important. It's just trying to get something that has kind of the shape that I feel like might make sense. So 0.3 comes out to 1. So that is in fact the shape that I was hoping to see. Okay. It would be our productivity function that turns ideal, baseline, and amount into an actual amount of productivity. So I'm just going to use that function now. Okay. So it's the productivity of the amount of interaction relative to a baseline given the ideal. Okay. And with that, all of the nodes are now not hatched. So we have an actual fully defined quantitative model. So we can actually look at what the result of any of these nodes are, like the final objective. And okay, and what that says is that it looks like the mid value, meaning we're ignoring certainty, but just kind of looking at what things are at the median. Mid value looks like we're not as productive, a little less productive than we would be in the office, not much less. The mean is kind of more significant. The mean says we're actually can expect to be a little more productive working from home. Okay, but now that's just under this particular choice of policy. So we want to figure out, what would be the ideal amount to work from home. So what I'll do is I'll just switch this to a sequence from 0 to 100%, say in increments of 5%. And now look at relativity again and the mean of relative productivity. And it looks like it kind of, I'm going to zoom in a little bit because it's stuck up there at the top. It actually looks like it is monotonically decreasing. Okay, so That's interesting. That's something I did not expect to see. I thought it might go the other way. So, I'm actually kind of curious why I see that. I'm just going to look around just a little bit because I like to. So at this point, when you see something that kind of surprises you, it's not a bad idea to look around a little bit and see why that might be. Because see, I thought the spontaneous interactions being low and being a lot different than the ideal would have some disadvantage here, but I'm not seeing that. So, which isn't the end of the line. I'm sorry. Actually, what this says is we're losing productivity. So actually, it's saying the less we're in the office, or the more we're in the office, the higher will be. Is it a good time to do a sensitivity analysis? It might be, yeah. Okay, so yeah, so this variation here, you notice actually, if you look at the bigger picture here with the zero from zero, it's not really that much variation. I mean, it's 20% or something. Let's look at the ability bands here. Okay, so especially in this range, it looks like our uncertainty is actually quite a bit larger than the actual amount of variation in that mean. I mean, substantially larger. Out here, it's maybe not as extreme. So, so yeah. So now, what's responsible for that uncertainty? Somebody just suggested we do an sensitivity. So let's do that. So select that. And one thing I want to mention is when we do this, we want to actually talk about, pick a spot. There's not a lot of uncertainty at the beginning here. I'm wondering why there's any uncertainty at the beginning. Actually, there's a something because our baseline is known. So wouldn't that just be 100%? That would be our baseline. Okay, so that makes me think I have something wrong in here. Did something weird. Anybody spotted it, but anyway, yeah, I feel like if our baseline is on there, we should be getting 0. I don't know. That's kind of counterintuitive to me. Okay, anyway, sorry. Anyway, so we want to pick some spot here that we really want to center on. So like, let's say at 30%, where there's a little more uncertainty, kind of understand where that uncertainty is coming from. I'm just not focusing at 0, even though that's where our best option is right now, because there's just not much uncertainty there. So anyway, so let's go ahead and do that uncertainty, but I'll hit make importance on relative productivity. And that's because somewhere there's something that's not uncertain. And we'll graph it. Okay. And I think here I basically want that 30% probably. Okay, and so this shows us which uncertainties are contributing to our overall uncertainty. And that's also a bit counterintuitive, but possibly correct. It's actually, even after spending all this time on interaction, it's saying that what we know about the relative productivity from working at home is actually dominating our uncertainty. So that's actually a really key insight, because that says that what we really want to do next probably, as we refine our model, is to really focus on that. So what kinds of things might be at our disposal for maybe reducing the uncertainty in this, but also maybe promoting this, maybe supporting this. So that might lead us to new decision opportunity ideas. Okay, so there's an example of how the concrete, even when it's sort of fictionalized, the concrete and the sensitivity analysis can actually help you discover new decision opportunities. Okay, which is a big part of all of this. So we haven't explored also required meetings. Might see what the effect of this is. So okay, so I will just stick a number of possible things there, and let's go back and look at our mean of this. Let's look at the mean. Okay, and what we see here is there's not a lot of variation from that at this point. So, oops, let me actually zoom slightly differently. I missed the zoom that I wanted there. What just happened here? Okay, there we are. I think just a second here. Woo-hoo. I'm waiting for something. I'm not sure what. Okay. All right. So, okay. So, yeah. All right. So I'm going to speed up a little bit. All right. So I guess looking at this, we see that there does seem to be a sweet spot, which is the 10%. It seems to be the best. It gets a little bit worse at 5%, but it doesn't make a huge difference. But anyway, these kind of things can lead to different ideas and questioning why they happen and stuff. It's that concrete that kind of springboards us to the next level. So where you go from here is you refine incrementally, trying to keep it running at each stage, but including additional refinement and ideas and so forth. Okay, so let's go back to some slides, and I'm going to zip through some final things here. So that was the exercise portion of this, which brings us to the next transition slide, which is software design. So, the that I focus on here is, given these hard decision situations without historic precedent, and given that these technologies that focus on data, like machine learning, aren't very applicable, what kinds of software tools can we design that can really enable us to do better at these situations? And so here, these slides is to kind of spur some conversation about what features of software are useful. And if you remember this slide of the various deficiencies that people have, question is, what is it about the software that can help us with these? And so what I have had here was a series of slides where we take each of these things, and I have everybody ask people to put ideas in the chat for what kinds of features of the software help us to avoid focusing too narrowly. Because I just got a message that we are nearing the end of the hour here. I'm going to kind of skip the interactive part here and just mention that I find there's quite a few different features that are useful for all of these things I put up here. So certainly making decisions and objectives explicit, as in influence diagrams, having the software support qualitative thinking, but yet be quantitative so that you can understand trade-offs, and to be concrete, right? Concreteness inspires, to make it easy to refine and reorganize and stuff, so you explore different decisions and different objectives, representing uncertainty, doing parametric analysis, sensitivity analysis. We've seen how that actually helped us identify a decision, and to assimilate problem complexity without cognitive complexity. So these are high-level design things, not like focusing on specific features. I don't like the word features. It's more how everything kind of designs together. The next thing would be like, how can software prevent anchoring and then help with advocacy and partisanship? And so, there's numerous ideas that come into this. I just want to fly through these, but an important one is to avoid lock-in to early ideas and avoid lock-in to early structural and dimensional commitments. Also, just kind of going down the list, making assumptions explicit so people can focus on those assumptions rather than on, having different objectives and not communicating that well. And being able to share models and interact with models, I think, is important. I'm not going to go over everything for time. How do you prevent decision paralysis, or how do you help with decision paralysis and help, this problem that people commit prematurely? Again, having a prescriptive approach for how to go forward, and especially having an approach that sort of gets concrete, gets qualitative initially, but lets you get concrete quickly. Those things I think are kind of a real key. And I think there's a lot of additional aspects to this. Again, I'm flying through for time. People rely too blindly on analytical results. And, what you need to do is you need to be able to combine insights from your models with things that aren't modeled. And for this, I would say, really different kinds of transparency are really key. And I kind of see there being at least two kinds of transparency. Referential transparency means that you can really look at any conclusion that you got, and you can really see where that came from. Something that is highly missing in some paradigms like optimization paradigms and program simulations. Granular transparency has to do with really being able to understand the model at all levels, visually without having to look at formulas and things like that. Any way the model can really emphasize insight over numbers, because it's more about gaining insight than it is about, predicting a precise number out of the end, is again, okay. And so again, that was meant to be kind of a discussion section, but I'm going through here. So at Lumina here, I develop Analytica, and my team and I work to design, take these ideas about how to design software to help with this problem. And we've embodied in Analytica, which is where we've been doing the exercise in. Analytica has been used by over 45,000 people in over 1,800 organizations and on many different application areas. Many of these are very high stakes and high profile, and there's been low stakes and things as well. I've used it a lot in my own personal decision making, for example. And that kind of gets us to applications. This final section here. And I thought it might be interesting just to mention some of the applications that have gone on at Lumina. So the Rigs to Reef project, one that a documentary movie was actually made about. So I put the link there at the bottom, and I think Mitsu might share that in the chat. So there are these big oil platforms off the Santa Barbara coast in California, and they are nearing the end of their lifespan. Oil's running dry and so forth. And so we're getting to the point of those need to be decommissioned of them. They're like, some of these are taller than the Empire State Building, and they've become the most bioproductive regions off the California coast. But they have been a point of contention for decades. They're site of one of the biggest oil spill in California history, and many different groups, have always had a hard time, just arguing about how they should be decommissioned. So we got involved with this, built a model of this, bringing all the different groups, various objectives and options together and assumptions, and let people play with the model. And we brought out of the 22 special interest groups, from fishermen to shipping interests to oil companies, environmental things, Greenpeace and the state of California, and legal defense funds that want to stick it to the oil company and so forth. Out of 22 interests, different groups that have interest in this, we got consensus where 20 out of the 22 came to the same conclusion, that they should be cut off 180 feet below sea level, the top toppled over to form a new reef, and leave them there, reduce. And so, and a bit more to it than that too. So it was a really neat thing. Again, I'll mention that also won an award for the most impactful decision analysis application of the year a few years ago. So distributed energy system planning model is a really amazing model, and I hope we have James actually do one of these webinars about this model. But it enables utility companies and people who might be considering various options, organizations, to look at things like solar PV and electric vehicles and energy storage, and how upgrading to use those kind of things at your facility or whatever could, what kind of impacts that would have on numerous different objectives. And it could be used, to look at how utility companies, from a utility company macro perspective, but also at the level of individual customers, to give them guidance on what would be best. And one of the interesting things there is the model, when used in a particular utility company, found that the sort of optimal type of balance between solar PV and battery solutions in residential and commercial was exactly the reverse of what was happening. So it's kind of neat. A 30-year energy plan. We helped Nigeria develop a 30-year energy plan to sort of jump start the renewable energy in the future, to really kind of strengthen their grid. They kind of lack the energy infrastructure that we're used to here, but it turned there were some good options to adopt solar in the northern part of the country and so forth. And we worked with the World Bank to sort of help them develop that plan. The future of the automobile. This model was designed to really help understand what future automobile technologies will look like under various assumptions and things that might happen. Will everything be electric cars? Will hydrogen cars come into play, and so forth. And a climate action planning model. This is an application basically that could be used by cities or campuses to sort of understand the impacts of their upgrades to various green technologies or other kinds of system upgrades. And in the case of cities, it might also help them understand what that means for their tax base. Okay, on another slide from that. Okay, this is running an ACP actually. It has kind of a slightly different look to it. Okay, and so last part I just wanted to mention resources. So first of all, if you are new to Analytica, and you want to, this made you curious, you want to try it out and possibly, use it, go to analytica.com and push that Try Analytica button, and you'll have a download there where you can get going with the free edition. And what you want to do is you want to start with the Analytica tutorial. Okay, I really recommend you go through that and you actually do it. So you don't just read it, but you actually do it yourself, copy it, and that'll get you going probably. And then the Analytica Wiki is the central resource for Analytica users with all the materials and reference materials and videos and all sorts of stuff that you might want to turn to when using Analytica. There's also the user guide on there and stuff. And then you might want to be, I really encourage people to be active in the Analytica community. We have an Analytica forum on the website, and we're really trying to get people to, it's fairly new, we're trying to get people to be active on there. This is the place where you should ask your technical questions. It's good to ask them in a public place where other people can also see the question and see the answers. And so that's actually nowadays the recommended place to send your questions, technical at least, and or other kinds of questions. And also subscribe to the blog, and so you'll see when other people, into the forum, and then you'll see when other people post, and you can answer their questions too. Just kind of participate. And the Lumina blog is a place where we post articles occasionally. It hasn't been too active recently. At the beginning of the pandemic, I wrote a whole series of articles on COVID and stuff. That was early on when it was clear that the COVID pandemic was somehow historical precedent. And so I thought it was very interesting to get involved early before people knew very much. So you'll see a whole bunch of articles from back then. And, it's been kind of quiet for a while, but hopefully you'll see more action there in the future. And then follow us on social media, at least some of these. We'll also, when you see things, if we do post stuff on the blog, we'll let you know on social media, whichever one is your favorite. All right. Mitsu has put links to all of these in the chat so that you can copy paste them if you need to. And that brings me to the end. So first, thank you everybody who was able to last through all that. And I wonder if there's any questions or comments. And I guess we have to do that in the chat or question box. I know it takes a little while to type, so I'm not going to cut this off too quickly.
I just wanted to say thanks, Lonnie, for taking the time to put this presentation together and to kind of walk through an example model of decision making in real time using the platform. I thought that was really fun.
Good. Okay. Yeah, I hope everyone else enjoyed that too. I know that's an aspect of my presentation is kind of different from how most people do things, but I tend to get in there and I like to kind of take things on live. It gives me some variety too. So what if people disagree about the details, quantities, which function units to use in the model structure? And that is to be expected actually, right? And you hope people do disagree. So disagreeing, and there's a lot of differences there. So there's some things which are disagreeing about the quantities or about estimates, which is one reason why having a usable model is really useful. And I want to say one thing I really advocate for is that people should consider a model to be a deliverable. So when you are in a decision situation, most people are used to delivering a report, kind of a written report that analyzes the situation, and then they pass that around. And I really think that's kind of a bad idea, even though that's what people are used to. So if you can pass the model itself around, then that gives people the flexibility to try different assumptions and different quantity, different estimates and things like that, and see what the impact is. So like in the rigs for reef example, there was still no agreement about many of the assumptions and the importance of different objectives. So there was great disagreement about that when consensus was reached about what the right decision was. So there are things like that happen. It's a little bit different when you disagree about the model structure, but I think really there it's a matter of trying to really understand, trying to work with and trying to sort of accommodate the thinking. I actually do think it's a good idea to explore multiple model structures, multiple different approaches at the same problem. Again, you often get different insights, and it helps you not to get too married to your quantitative results. If you look at the article on our blog, where I, at the when it was pandemic was going to hit the United States soon, I basically went through an assessment exercise to estimate how many people would die from COVID in the year 2020. And in there, you'll see that I made a big emphasis on you really should go about this with multiple different approaches, multiple model structures, to really kind of get a full picture. And so now, what if you're not sure that you've done this right, and maybe you've missed something really important? And so how can you verify and validate models like this? And that's a really good question, because to a large extent we're dealing with something that has no historical precedent. So you can't necessarily compare it to a specific outcome and say, yeah, that matches the frequency of this outcome, because it's never happened before. So I think the real key there is, as you're doing this, you want to look for all the things that seem counterintuitive or things that you don't understand. Okay. So when you do this, you find many surprises, and those can be good, but you want to understand every surprise. And so that can help you really zero in on if you've had mistakes. You also, do want to get other people's feedback. Then finally, what you want to do is you want to keep a record of your decision, of your model, and then come back to it later and reevaluate what you did right and what you did wrong, and make sure your model kind of documents what you knew, and kind of your probabilities kind of document. You often these things are possible, but you really didn't. You had a certain belief about their likelihood, and in hindsight, you'll think you should have known that was going to happen, because you reinvent the future. So, but coming back and doing that will help improve your skill. So a lot of this is about your own skill, yeah. So it's kind of like, every day in the stock market, what's going to happen tomorrow? Well, I know it could crash, give you reasons why it might. I know it might actually skyrocket, and I give you reasons it might. And then tomorrow it's like, I knew that, right? I should have sold everything. But the reality is, you go back, you look, you say, well, I didn't actually know that was that likely.